In number one, I see higher exponents. So what I'm going to do is split this into two parts. We're going to factor difference of two squares, which is a squared minus b squared equals a minus b, a plus b. And so this will be cosine squared for cosine to the fourth. And then this will be, I need more room, cosine squared plus sine squared,
Okay.
and then cosine squared minus sine squared
Okay, you separate.
to get those sine to the fourth. Now, when you have cosine squared plus sine squared,
Yeah, you can do that.
is, let's find it on the note card, cosine squared plus sine squared is 1.
No, because
so that's
you would have to
Pythagorean.
have 1 over tangent, because if you have this, then this
So
is
now
just
I
1
have
altogether
cosine squared
without
minus
the bottom.
sine squared.
So you have to have it as 1.
And when I look at what I want, I need that negative sine squared, but I need another one because there's two of them. So I'm going to change cosine squared into a sine squared
And then you
using the
separated
same
out
property.
this.
So
You can't
cosine
do that
squared
either
I can
because
replace if I subtract sine
then
squared over
this
to
is
the 1.
implying that the bottom is also
So this becomes
squared.
1 minus sine squared.
How would you go?
Now there's two of them that you can subtract to make 2 sine squared. And now we get what we wanted. Number 2, I see two fractions together, and at the end there's only one term. So that tells me common denominators. So to get a common denominator, I need a cosine on the bottom of the second fraction. So I have 1 over sine cosine minus, when I give cosine to this one, it'll be cosine squared over sine cosine. Now they have matching denominators, and then you can subtract them. So on top, you have 1 minus cosine squared, and you want to look for how to change it into tangent. So we want sines and cosines. I don't want subtracting anymore, so I'm going to go to my Pythagorean properties, and I notice that if I subtract cosine squared to the other side, I get sine squared. So I can change the whole top into sine squared. If the top is sine squared, then now I have a sine on top and I have a sine on the bottom, which will cancel, and I have sine over cosine left over. And if you look at your quotient properties, sine over cosine is tangent, and that is what we want to prove. So that's how you would do number 2. Number 3, we're going to get a common denominator, but I don't want cosecants and secants together. Because if you look at your Pythagorean properties, cosecant and secant are not in the same property together, so you don't want to use them very often. What you want to use is cosines and sines because they are in a property together. So I'm going to change cosecant into 1 over sine, and I'm going to change secant into 1 over cosine, which are reciprocal properties. And so I've got sine over a fraction, cosine over a fraction, and when you are dividing by fractions, you need to multiply by the reciprocals. So I've got sine on top times reciprocal 1 over sine, which is sine over 1, plus I've got cosine times reciprocal of that, cosine over 1. Now, those make sine squared, those make cosine squared, those make 1. So that's how you get to your 1. Okay, number 4. When I look at this, I don't see how anything is compatible on the left to the right. So when you are out of things to try the conjugate. So if 1 plus cosine is the factor I have, I'm going to try 1 minus cosine, and I'm going to put it on top and on bottom. So on top, I now have 1 minus cosine. I don't know why I did C. Those should be S's. 1 over cosine S over, and now I've got 1 plus cosine times 1 minus cosine. I'm going to FOIL those. So 1 times 1 is 1. 1 times negative cosine is negative cosine. Cosine times 1 is positive cosine. And then cosine times negative cosine is negative cosine squared. Now when I FOILed, that cosine and negative cosine cancel. So I have 1 minus cosine on top over 1 minus cosine squared on the bottom. Now the bottom is Pythagorean. If I subtract cosine squared to the other side, I get sine squared. So the bottom changes into sine squared. And if I want cosecant minus cosecant cotangent, I can split this into two fractions and make this 1 minus, or 1 over sine squared minus cosine over sine squared. That 1 minus sine squared becomes cosecant squared that you need. And then the cosine over sine squared, this you can split into two sines. And one of them, cosine over sine, becomes the cotangent. And then the other 1 over sine becomes the cosecant. And that's how you get what we want. So on the bottom, we're going to change tangent squared into its Pythagorean property because I want to get these fractions compatible and get common denominators and put them together. So when you look at tangent squared, that becomes secant squared minus 1 if I subtract 1 to the other side. So I've got cosine on top and then secant squared minus 1 on the bottom now. They're still not compatible. I want to factor this. So I'm going to take this and factor difference of two squares. Secant plus 1, secant minus 1, and that splits your square up. Now I can see where to get the common denominator. I have a secant minus 1. I need a secant plus 1. I need a secant plus 1. Now, that is going to give me, I'm going to distribute this cosine. So that'll be cosine secant plus cosine over secant minus 1, secant plus 1, and then minus the other fraction, which is just cosine on top and those common denominators. And now you can take cosine secant, and that is a reciprocal property, and it becomes a 1. You also, when you subtract the cosines, make 0, so you just have 1 on top over your common denominator. Now, your common denominator, we're going to re-FOIL back together. But remember, we already factored it earlier. So if I FOIL, I'm just going to get back to secant squared minus 1. And when I get back to secant squared minus 1, I get back to tangent squared. And 1 divided by tangent is cotangent. So that's how you get cotangent squared. So this is one of those cases where we had something we needed. We had to get rid of it and change it into secants and then get it back at the end. So we got rid of it and then we had to bring it back.